All right, for example 61, in this modeling it says the theater has 30 rows, okay, of 20 seats. All right. Now it's asking you or telling you that tickets for seats in the N rows closest to the stage cost $45. Okay, so what this problem is saying is there's N rows at $45 a piece. Okay, and then all the remaining rows are at $35 a piece. All right, so if there's a total of 30 rows and N of them represent that $45 charge, how many rows are going to be left at 35 apiece? Okay. Good. So a total of 30 minus the number that represent those more costly seats. So here there's going to be 30 minus N seats at 35 and N seats at 45. So, or N rows at 45. So when we look at the expression for this, so if we were to model this information, we have 45N, and then we're going to add that to 35 times 30 minus N. Okay, and so when we look at this solution, what we can do is we can identify, distribute our 35, and identify an expression to represent this whole thing. So if we take 35 times 30, okay, we get 1,050, and then minus 35N. And if we combine our like terms here, 45N minus 35N is 10N plus 1050. So here's the expression that gives us the number of rows, where N is the number of rows, right? So when we look at this, if we know that this is the charge per row, how many seats are there per row? There's 30 rows of 20 seats. And so when you look at that, you have to multiply this whole thing by 20 to get the total amount that you're going to charge, or the income generated from these. So if we distribute the 20 through, 20 times 10 is 200N plus 1050, or 1050 times 20 gives you 21,000. Okay, and so 200N plus 21,000 is what your ultimate expression for the income would be.